Imagine this: a massive object, traveling through space at extraordinary speeds, unexpectedly enters our solar system. It's not a comet, not an asteroid, but something entirely different, an interstellar visitor, unlike anything we've ever seen. And it's not just passing through, it's behaving in ways that defy our understanding of cosmic objects. What's even more shocking, this object, named 3IATLAS, has all the characteristics of an alien probe, quietly observing us from a distance. But is it really a relic of another star system, or could it be something more extraordinary? Could it be a highly advanced spacecraft sent with a mission to monitor us? Discovered by the Atlas Observatory in Chile on July 1, 2025, this object instantly captured the attention of scientists around the world. It's not just any space rock. This thing is huge, with an estimated size 100 times bigger than ʻOumuamua, the last interstellar object to visit us. 3IATLAS stands as a giant among cosmic travelers. But it's not its size that makes it so interesting, it's the way it's moving. Unlike the normal, predictable paths of comets or asteroids, 3IATLAS has a bizarre retrograde trajectory, almost as if it's been intentionally steered, bypassing planets, passing close to the sun, and cruising on a path that just seems unnatural. And here's the real kicker: it doesn't behave like a typical comet. It's not releasing any of the expected gases or forming a tail. In fact, its complete lack of cometary activity is what has sparked heated debates among astronomers. Is this a natural object with unique characteristics, or is it an artificial probe sent by an alien civilization designed to remain unnoticed while gathering information about us? In today's video, we'll delve into the mystery of 3IATLAS, exploring its strange trajectory, its curious composition, and the shocking possibility that it could be a piece of extraterrestrial technology sent to monitor life on Earth. Is it a coincidence? Or is it the first sign of extraterrestrial intelligence? Stay tuned, because what we uncover might just change everything we thought we knew about the universe. The discovery of 3IATLAS, an interstellar object like no other, has sent shockwaves through the scientific community. It all started on July 1, 2025, when automated systems at the Atlas Observatory in Chile made an unexpected and stunning observation. Astronomers had been scanning the skies for potential interstellar objects, as the discovery of such objects has become an increasingly fascinating pursuit in recent years. However, nothing could prepare them for the colossal discovery that was about to unfold. 3IATLAS is the latest and most extraordinary interstellar object to cross our solar system, and its discovery marks a significant milestone in our ongoing quest to understand the mysteries of space. But this discovery wasn't just another cosmic object passing through the neighborhood. It was unlike anything anyone had anticipated. While previous interstellar objects such as the infamous ʻOumuamua in 2017 and Borisov in 2019 caught our attention due to their peculiar trajectories and features, 3IATLAS raised the stakes to a whole new level. Interstellar objects, by definition, are not bound by the gravitational forces of our solar system. They are wanderers, moving freely through the vast expanse of space, often coming from distant star systems. The first of its kind, ʻOumuamua, arrived with a frenzy of speculation. Its cigar-like shape, rapid speed, and erratic behavior led some to speculate it might not be a natural object at all. Then came Borisov, another interstellar visitor that behaved more like a typical comet, though it still came from outside the solar system. These objects sparked debates and discussions across the scientific world, but 3IATLAS takes the conversation to a whole new dimension. What makes the discovery of 3IATLAS particularly significant is not just its arrival, but its composition, trajectory, and most notably its massive size. Unlike ʻOumuamua and Borisov, which were relatively small in comparison, 3IATLAS is an absolute giant, measuring around 100 times larger than ʻOumuamua. Imagine that, a massive object hurtling through space at incredible speeds, defying our expectations and landing right in our own cosmic backyard. It wasn't just large in size, but it was also composed of some incredibly intriguing materials, including water ice and organic compounds, components that are foundational to life itself. This object isn't just a floating rock, it's a time capsule, possibly containing the secrets of distant star systems and planets, and could offer us a glimpse into the building blocks of life in the universe. But let's take a step back. Before the discovery of 3IATLAS, the idea of interstellar travel and exploration was something largely confined to the realm of science fiction. The idea of other civilizations out there in the cosmos capable of sending probes or artifacts across the vast distances between stars seemed like a far-off dream. Sure, scientists like Dr. Abraham Loeb, who first proposed that ʻOumuamua could be an alien probe, sparked curiosity, but many in the scientific community were hesitant to jump to such conclusions. But the data coming from 3I-ATLAS has made one thing clear: the possibility of interstellar objects not only traveling through our solar system but potentially being engineered or modified in ways we can't yet understand is something that demands serious consideration. Once 3I-ATLAS was discovered, a large number of astronomers from around the globe scrambled to observe and track its trajectory. This was no small feat, as the distances involved are mind-boggling. The object was already millions of miles away from Earth when it was first detected, but its size and trajectory were so out of the ordinary that it became impossible to ignore. What really set 3I-ATLAS apart from its predecessors was its unusual orbit. Unlike other interstellar objects, which tend to follow typical paths influenced by the gravitational pull of nearby stars and planets, 3I-ATLAS was on a path that seemed deliberately engineered. Its retrograde orbit, the fact that it travelled in the opposite direction of most objects in our solar system, was unlike anything seen before. This peculiar behaviour prompted speculation. Was this natural, or was there something more at play here? The trajectory of 3I-ATLAS made it seem as though it was intentionally avoiding the gravity wells of larger planets and stars, which is an oddity for any object in space. It almost appeared as though 3I-ATLAS was deliberately passing close to the Sun, Earth, and even Jupiter, all while evading the expected gravitational influences that should have altered its course. Could it be that this object was being steered? One of the most exciting aspects of 3I-ATLAS's discovery is how it challenges our understanding of interstellar objects. These objects are often thought to be random wanderers, hurling through space with no direction or purpose, but the sheer precision of 3I-ATLAS's path suggests there might be something more deliberate behind its movements. This is where the theories of extraterrestrial life and advanced technology begin to emerge. Could 3I-ATLAS be an artificial probe? Could it be the work of an alien civilization that intentionally placed it on a path that would bring it through our solar system? And if so, what was its purpose? In addition to its trajectory, the composition of 3I-ATLAS provides another tantalizing clue about its origins. Unlike typical asteroids or comets, which are composed mainly of rock and ice, 3I-ATLAS is made up of a unique mixture of water, ice, and organic compounds, chemicals that are essential for life as we know it. This is the kind of material scientists would expect to find on planets in the early stages of forming life, or even on moons and planets where microbial life may exist. But the key here is that 3I-ATLAS has remained in an almost pristine state, untouched by cosmic radiation and other environmental factors that would normally degrade its structure over time. This means that the object has not interacted with the harsh environments of space for billions of years. It could be a snapshot of a time long ago, frozen in time and offering us a glimpse of distant star systems. 3I-ATLAS's composition also holds the potential to answer fundamental questions about the building blocks of life. Could the organic compounds found on this object be evidence of life beyond Earth? Or perhaps just the raw materials needed for life to develop? As the object makes its way through our solar system, scientists are rushing to study its properties, using high-tech instruments to analyze its structure, chemical makeup, and even its temperature. The information gathered from 3I-ATLAS could be the key to understanding the origins of life in the universe and whether life could exist in other parts of the galaxy. In the coming months and years, as 3I-ATLAS continues its journey, it will provide a treasure trove of data, potentially answering questions that have haunted humanity for centuries. Are we alone in the universe? Could other civilizations have existed before us, and could they have left evidence behind, in the form of objects like 3I-ATLAS, to silently observe the rise of life on Earth? The answers to these questions could reshape our understanding of life itself and the vastness of the universe we live in. 3I-ATLAS might just be the first step in a new era of discovery that will continue to unravel the mysteries of our cosmos for generations to come. As the investigation of 3I-ATLAS unfolds, scientists are finding themselves at the edge of a discovery that could change everything. But what happens next? Will we find answers about its origins, or will we continue to be left wondering about the true nature of this mysterious object? Stay tuned, because this story is just beginning. The first question that arises when discussing the discovery of 3I-ATLAS is what makes this object so unique. For starters, its sheer size and composition immediately set it apart from previous interstellar visitors. While ʻOumuamua and Borisov, the two most famous interstellar objects we've encountered, were intriguing in their own right, They were relatively small and their compositions were not as extraordinary. 3I-ATLAS, however, is a game changer. Its size, materials, and pristine condition offer new insights into the nature of interstellar objects and raise new questions about the potential for life beyond Earth. Let's begin with the most striking feature of 3I-ATLAS, its enormous size. At roughly 100 times the size of ʻOumuamua, this object dwarfs its predecessors in terms of mass and scale. The sheer scale of 3I-ATLAS puts it in a category of its own. While ʻOumuamua was estimated to be just 800 meters long and 80 meters wide, 3I-ATLAS is significantly larger, with a length that is thought to exceed 1.5 kilometers, massive by any standard for an interstellar object. The size of 3I-ATLAS is one of the key factors that make it stand out in the astronomical community. Such a large object could provide much more material to study and is more likely to contain traces of valuable information about the star system from which it originated. Scientists have long speculated about the origins of interstellar objects and what their size, speed, and composition can tell us about their home systems. The size of 3I-ATLAS gives it a kind of cosmic credibility. It's large enough to potentially hold answers to questions that smaller objects like ʻOumuamua couldn't. But the question remains, why is this object so large, and why does it seem to be so pristine, despite traveling through space for billions of years? When studying interstellar objects, scientists often examine their physical properties, looking for clues about their formation and the environments they have passed through. Interstellar objects travel through vast, cold regions of space, and this design can take them through regions filled with cosmic radiation, solar wind, and other hostile conditions that would normally degrade or destroy smaller bodies. Yet 3I-ATLAS seems to have avoided this fate. Its preservation suggests that it has been traveling through space relatively untouched, its surface free from the ravages of radiation or environmental degradation. This pristine condition is both a mystery and an opportunity, as it could allow scientists to study the object as a time capsule from a distant star system. What truly sets 3I-ATLAS apart from other interstellar objects is its unique composition. When astronomers first observed 3I-ATLAS, they found that it contained large amounts of water ice, an essential ingredient for life as we know it. This is not unusual for comets, which often contain a mixture of water ice, dust, and other organic compounds, but it is unusual for an object of this size and origin to have such a high proportion of water ice. Water is one of the key building blocks of life, and the presence of water ice on 3I-ATLAS could offer significant clues about the potential for life beyond Earth. But it's not just water ice that makes 3I-ATLAS fascinating. It's also the presence of organic compounds. Organic compounds are molecules that contain carbon and are fundamental to life. They form the basis of all known biological systems, and the discovery of organic compounds on 3I-ATLAS raises the tantalizing possibility that these compounds could have been transported from one star system to another. Could these compounds have played a role in the development of life elsewhere in the galaxy? Could they have contributed to the formation of life on Earth, potentially arriving here via objects like 3I-ATLAS? While we may never know the full extent of this object's role in the broader cosmic story, its presence in our solar system is a valuable opportunity to study the complex chemistry that exists in interstellar space. The discovery of organic compounds on 3I-ATLAS could also have profound implications for our understanding of planetary formation. We know that comets and asteroids, which are often composed of ice and dust, play a crucial role in the formation of planets. They deliver essential materials, such as water, carbon, and other key elements to young planets. Could 3I-ATLAS be a cosmic messenger, delivering life-essential compounds from a distant star system to a planet somewhere far away? If it is, then its journey through our solar system might just be the latest chapter in an ongoing saga of planetary evolution that spans billions of years. The pristine state of 3I-ATLAS is one of the most intriguing aspects of its discovery. The object's preservation suggests that it has not been exposed to the usual cosmic radiation and environmental conditions that tend to break down interstellar objects over time. Given that it has been traveling through space for billions of years, this raises the question, why has 3I-ATLAS remained so intact? One possibility is that it has been shielded from the worst effects of radiation by being located in a cold, dark region of space, far away from the radiation of stars and the disruptive forces of nearby celestial bodies. Another possibility is that 3I-ATLAS is made of materials that are highly resistant to cosmic radiation and environmental wear. Its water ice and organic compounds might be in a form that can endure the harsh conditions of space without breaking down. This idea is supported by the fact that many of the most important chemicals for life on Earth, such as amino acids, are quite stable when preserved in ice. The object's pristine condition could mean that it's preserved valuable information about the star system from which it originated, information that could reveal important clues about the conditions in other parts of the galaxy. If 3I-ATLAS is truly a time capsule from another star system, it could offer us a glimpse into the history and evolution of distant solar systems. The combination of size, composition, and pristine condition in 3I-ATLAS has led to increasing speculation about its true nature. Could this object be something more than just a random space rock? Some researchers have even suggested that 3I-ATLAS could be an artificial object, a probe sent by an advanced alien civilization. The idea that this interstellar object might not be a natural object at all, but a product of extraterrestrial technology, raises fascinating questions about the nature of life in the universe. If 3I-ATLAS is a probe, what is its purpose? Is it monitoring life on Earth? Is it simply a scout for a more advanced civilization, gathering information before they make contact with humanity? The mystery surrounding 3I-ATLAS, combined with its unusual trajectory and composition, makes it a compelling candidate for further investigation. It could hold the key to unlocking one of humanity's most profound questions. Are we alone in the universe, or are we just one of many civilizations scattered across the stars? As 3I-ATLAS continues its journey through our solar system, astronomers around the world are closely monitoring its movements and analyzing its composition. The data we gather from this object will likely be some of the most valuable ever collected from an interstellar visitor. The story of 3I-ATLAS is far from over, and its discovery is only the beginning of a new chapter in humanity's understanding of the cosmos. Whether it's an object of natural origin or an alien probe, 3I-ATLAS presents an extraordinary opportunity to learn more about the universe and to challenge the assumptions we've held about life beyond Earth. As more information comes to light, one thing is certain: the discovery of 3I-ATLAS is just the start of what could be one of the most exciting and transformative periods in human history. It's a mystery that may one day reveal the answers to questions that have kept us awake for centuries, and in doing so, it may finally show us that, in the vast expanse of the universe, we are not as alone as we once believed. The mystery surrounding 3I-ATLAS deepens when we examine its unusual trajectory. Unlike typical asteroids or comets that follow relatively predictable orbits governed by the gravity of the Sun, 3I-ATLAS has defied expectations by taking a strange and seemingly deliberate path through our solar system. Its trajectory has become a central point of intrigue for scientists, as it exhibits characteristics not seen in other interstellar objects. Understanding its path is crucial to piecing together the puzzle of what 3I-ATLAS really is, and why it has come to visit our corner of the galaxy. Interstellar objects by definition travel through space without being bound by the gravitational forces of any particular star. They are free agents in the cosmos, wandering from one star system to another over the course of millions or billions of years. Because of this, scientists expect these objects to come from distant parts of the universe, and their paths should follow the laws of gravitational dynamics. For instance, when a comet or asteroid enters our solar system, it typically follows an elliptical orbit around the Sun, guided by the Sun's gravity. In the case of interstellar objects, however, the trajectory should be affected by the gravity of nearby stars and planets, causing them to follow a predictable path. However, 3I-ATLAS has shown behavior that does not fit this traditional mold. When astronomers first began tracking the object's movement, they noticed something strange. Its orbit is retrograde. This means that instead of following the same direction as most other objects in our solar system, which orbit the Sun in a counterclockwise motion, 3I-ATLAS is traveling in the opposite direction. This retrograde orbit raises eyebrows because it suggests that 3I-ATLAS is not following the standard gravitational paths one might expect. In fact, it almost seems as though the object is deliberately avoiding gravitational forces in a way that suggests some form of control. When objects from outside our solar system enter our cosmic neighborhood, we expect them to be influenced by the Sun's gravity, which would bend their path in a way that brings them closer to the center of our solar system. But 3I-ATLAS isn't following this standard pattern. Instead, it seems to have been on a trajectory that doesn't align with the expected behavior of an object simply passing through our star system. This unexpected retrograde orbit has led some scientists to speculate that 3I-ATLAS might not be a natural object at all. Could it be that this trajectory is the result of intentional steering by an external force, perhaps an intelligent one? The object's precise path through our solar system is also striking. As 3I-ATLAS passed close to Mars, Earth and Jupiter, its movements appeared to be calculated. The trajectory was unlike anything observed in previous interstellar visitors, and it seemed to avoid interacting with the larger bodies in our solar system. The precise, almost deliberate manner in which it avoided gravitational interactions has raised significant questions. Was this the result of natural forces, or is it possible that 3I-ATLAS was deliberately guided along its path? The precision with which it navigated through the solar system, bypassing the gravitational wells of large planets like Jupiter and Earth, seems almost too deliberate to be a random coincidence. As we examine 3I-ATLAS's trajectory in more detail, it's clear that the object has been designed or at least guided through our solar system. To avoid the gravitational influences of the Sun and planets, 3I-ATLAS must have been traveling at an incredibly high velocity, much faster than a typical comet or asteroid. This rapid movement would have allowed it to pass through our solar system quickly, without being pulled off course by the Sun's gravitational field. But why? Why would an object, if it is indeed an artificial probe or spacecraft, need to travel through our solar system at such speeds and with such precision? The notion of a deliberately placed object in our solar system brings us to the controversial but tantalizing idea that 3I-ATLAS might be an extraterrestrial probe, an artifact from an advanced alien civilization. One of the most widely discussed theories about 3I-ATLAS's trajectory is that it could be a part of an intelligence-gathering mission. If we assume that 3I-ATLAS was indeed sent by another civilization, its path could be interpreted as a calculated survey of our star system, perhaps a mission designed to gather data on the Earth and its inhabitants. If this is the case, the purposeful route of 3I-ATLAS through our solar system may not be a random event at all. Instead, it could be a form of surveillance, an effort by an alien species to monitor us while remaining undetected. To add weight to this theory, we can also consider the context of the dark forest theory, which is a popular concept in the search for extraterrestrial life. According to the dark forest hypothesis, civilizations in the universe remain silent and hidden because they fear the consequences of revealing themselves to others. The idea is that the universe is like a dark forest, with each civilization acting as a predator that must stay quiet to avoid being destroyed by more advanced civilizations. If 3I-ATLAS is indeed an alien probe, its stealthy approach could be explained by this theory. The object may have been deliberately placed on a trajectory that minimizes its visibility and interaction with our solar system, allowing it to observe us without making its presence obvious. If it is a probe, its mission may be one of passive observation, collecting data on the Earth and possibly other planets while avoiding direct interaction. If 3I-ATLAS is indeed an alien probe, the way it travels through our solar system would suggest that its creators have advanced technological capabilities, possibly far beyond our own. The ability to send an object across the vast distances of space, to navigate through our solar system with such precision, and to maintain its secrecy raises profound questions about the nature of extraterrestrial intelligence. Could this be evidence of a highly advanced civilization that has mastered interstellar travel and reconnaissance? Or could it be a relatively small, exploratory mission sent by a civilization looking to learn more about our star system and its inhabitants? The lack of clear cometary activity in 3I-ATLAS further fuels the speculation that this might be no ordinary cosmic traveler. Comets are typically known for their distinctive tails and outgassing of material as they approach the Sun, but 3I-ATLAS exhibits none of these expected behaviors. Despite its size and proximity to the Sun, the object shows no sign of releasing the gases and dust that would form a tail, a characteristic of typical comets. This anomaly adds to the theory that 3I-ATLAS might not be a comet at all, but a carefully constructed and engineered object that was designed to blend in with the natural objects we encounter in space. What makes this even more intriguing is the possibility that 3I-ATLAS has been in space for much longer than we can imagine. If it has been traveling through interstellar space for billions of years, then it could be a relic from another time, perhaps even a probe sent out by an ancient civilization long gone. The idea that 3I-ATLAS could have been sent by a now extinct species, whose mission has outlived its creators by eons, adds another layer of mystery to the puzzle. Could this object be one of many sent out into the galaxy, silently collecting data and transmitting it back to its creators? If so, we may have just discovered a piece of the puzzle in our search for extraterrestrial life. Ultimately, 3I-ATLAS is more than just an interstellar object. It's a cosmic enigma that forces us to confront questions about the nature of life, technology, and the unknown. Its strange retrograde trajectory, combined with its massive size and peculiar lack of cometary activity, leads us to speculate about its true nature. Is it a natural object, simply behaving in ways that challenge our understanding of space? Or is it something more, a probe, an artifact, a messenger from an alien civilization that has watched us unnoticed for far longer than we've realized? As scientists continue to track 3IATLAS, one thing is clear: its journey through our solar system is far from over, and the questions it raises will likely continue to haunt us long after it has passed. As we delve deeper into the mystery of 3IATLAS, one theory continues to stand out due to its provocative nature: the possibility that this interstellar object is not a natural space rock or a comet, but an alien probe, a highly advanced piece of technology sent from a distant civilization. The idea that 3IATLAS could be a spacecraft designed for observation, potentially even a reconnaissance mission, challenges everything we know about extraterrestrial intelligence and our place in the cosmos. This theory brings us to one of the most intriguing and controversial concepts in modern astrophysics, and the search for extraterrestrial life: the dark forest theory. The dark forest theory, first introduced by Chinese author Liu Cixin in his science fiction series The Three-Body Problem, provides a stark and unsettling view of the universe. According to this theory, the cosmos is like a dark forest, where every civilization is like a hunter, trying to survive while being constantly on the lookout for other hunters. In this scenario, any civilization that reveals itself risks being destroyed by more advanced civilizations. The theory is based on the assumption that, in a universe teeming with unknown life forms, any species would need to remain hidden in order to protect itself. The analogy of the dark forest illustrates the deep fear that any advanced civilization would have of making contact with others, fearing the potential threat posed by unknown and possibly more powerful civilization. Could 3IATLAS be a product of this dark forest phenomenon? Is it possible that this massive object, moving through our solar system, was sent by an alien civilization trying to learn about us without drawing attention to themselves? Could it be a form of cosmic surveillance, with the intention of observing Earth and our solar system while avoiding any form of direct contact? The evidence seems to support this idea, given the object's peculiar trajectory, its deliberate maneuvering through our solar system, and its lack of typical cometary activity, which might otherwise suggest it's just another cosmic wanderer. The behavior of 3IATLAS raises more questions than it answers. First, there's its retrograde orbit. This unexpected path, which defies the normal motion of objects in our solar system, suggests that 3IATLAS is not simply drifting through space. Its trajectory seems almost too precise, as if it is intentionally avoiding gravitational pulls, navigating through our solar system with a deliberate strategy. This is a significant departure from the random and chaotic paths of most natural objects. It hints at the possibility that 3IATLAS is not just a passive observer, but an active participant in a larger plan, a cosmic surveillance mission designed to collect data on Earth without detection. What makes this theory even more compelling is the fact that 3IATLAS has passed close to several key planetary bodies, including Mars, Earth, and Jupiter. Its close proximity to these planets could suggest that the object is collecting data or observing the behavior of our solar system's planets. The possibility of an alien probe monitoring our planet as part of a larger interstellar mission is an unsettling thought, yet it's not an entirely new concept. In fact, the idea of extraterrestrial surveillance is something that has been speculated about for decades. From the famous search for extraterrestrial intelligence SETI to the possibility of alien probes, humanity has long wondered whether we are being observed by beings from other star systems. The complete lack of cometary activity in 3IATLAS further bolsters the idea that it may be a probe rather than a natural object. Comets, which are typically made up of ice and dust, exhibit a spectacular tail as they approach the Sun due to the outgassing of volatile compounds. However, 3IATLAS has shown no signs of this typical cometary behavior. It doesn't have a tail, and there are no visible signs of gases being emitted from it. In fact, its composition appears to be more solid and stable than what we would expect from an object that has traveled through space for billions of years. This lack of outgassing could be a feature of its design, suggesting that it is not a natural comet at all, but a carefully engineered object meant to stay undetected. If 3IATLAS is indeed an alien probe, its creators must have had advanced technology at their disposal. The fact that it was able to travel through the vast reaches of interstellar space and arrive at our solar system with such precision indicates a high level of technological capability. The probe would have had to endure the extreme conditions of space for billions of years, possibly traversing vast distances from another star system while maintaining its integrity and functionality. This suggests a level of sophistication far beyond our current technological capability. Could such a civilization exist out there, capable of building probes that travel between the stars, observing distant worlds without ever making their presence known. If 3I-ATLAS is a probe sent by an alien civilization, one of the most significant questions we must ask is why would they choose to send it to Earth? The answer, of course, lies in the nature of space exploration. For civilizations advanced enough to build interstellar probes, the objective would likely be to gather data on other planets, particularly those that might harbor life. Earth, with its abundant life and unique ecosystem, would be a prime target for observation. In fact, our planet is the only one known to harbor life, making it a key area of interest for any extraterrestrial civilization seeking to understand the conditions that foster life. The idea of observing Earth without revealing one's presence fits well within the framework of the dark forest theory. Any advanced civilization that has the technological means to travel across star systems would likely be cautious about making contact. As the dark forest theory suggests, revealing oneself to potentially more advanced civilizations could be a fatal mistake. Instead, the best course of action would be to remain undetected while observing, gathering information to understand whether contact with another civilization is safe or if it is even necessary. In this context, 3I-ATLAS could be a reconnaissance mission sent to monitor Earth and gather data on our planet's biological, atmospheric, and technological conditions. If 3I-ATLAS is indeed an alien probe, its lack of interaction with other objects in our solar system could be explained by the desire to maintain stealth. By avoiding gravitational interactions and flying under the radar, 3I-ATLAS would be able to gather information without drawing attention to itself. Its path through the solar system could be part of an extensive surveillance mission, where the probe is carefully following a preordained route that minimizes the likelihood of detection. The concept of alien probes is not entirely speculative. In recent years, more attention has been paid to the idea that extraterrestrial intelligence may be monitoring our solar system. The discovery of ʻOumuamua in 2017, with its strange shape and unexplainable acceleration, fuels speculation that it could be a probe sent by an advanced civilization. The unusual properties of ʻOumuamua, including its sudden speed change and lack of a typical tail, led some researchers to suggest that it could be a piece of technology rather than a natural object. Similarly, 3I-ATLAS fits many of the same parameters. Its large size, mysterious trajectory, and unusual composition point to the possibility that it could be part of a larger extraterrestrial mission. If 3I-ATLAS is indeed a probe, it would represent the first concrete evidence that extraterrestrial intelligence has sent a machine to explore our solar system. The implications of such a discovery are profound. Not only would it confirm that intelligent life exists elsewhere in the universe, but it would also suggest that this life is advanced enough to send probes across vast interstellar distances. This would change our understanding of life in the cosmos, and could open up new possibilities for contact with extraterrestrial civilizations in the future. As 3I-ATLAS continues its journey through our solar system, scientists are working around the clock to gather as much data as possible. The ongoing study of this object is crucial, as it may provide new insights into the origins of life, the conditions necessary for life to thrive, and the possibility of advanced extraterrestrial civilizations. Whether 3I-ATLAS is a natural object or a sophisticated alien probe, its presence in our solar system is a reminder of the vastness of the universe and the mysteries that still lie ahead. In the coming years, we will continue to track 3I-ATLAS and analyze its composition, trajectory, and behavior. With the help of advanced telescopes, space missions, and scientific collaboration, we may one day unlock the secrets of this mysterious visitor. Could 3I-ATLAS be the first sign of extraterrestrial intelligence? The answers remain elusive, but the discovery of this object is a step closer to understanding the vast and enigmatic cosmos that surrounds us. As we watch its journey unfold, we are reminded that the universe is full of surprises and that humanity's search for life beyond Earth is just beginning. As the mystery of 3I-ATLAS continues to unfold, the question of whether it is truly an alien probe or simply an odd natural object remains a central point of debate among scientists. While some researchers are ready to embrace the idea of it being a part of an extraterrestrial intelligence's mission, others are more cautious, leaning toward natural explanations. This divide in scientific opinion underscores the complexity of the object itself and the challenges we face in interpreting what we're observing. However, as much as the scientific community has hesitated to jump to conclusions, the discovery of 3I-ATLAS has reignited an important conversation in the search for extraterrestrial life and the ongoing search for intelligence beyond Earth. The initial excitement surrounding 3I-ATLAS came from the unexpected nature of its discovery and the strange characteristics it exhibited. The object was first detected by automated systems at the ATLAS Observatory in Chile, which are tasked with scanning the sky for potential threats to Earth, such as near-Earth objects. The ATLAS system, an integral part of global efforts to monitor the skies, had previously helped identify interstellar objects like ʻOumuamua and Borisov. But the discovery of 3I-ATLAS was in many ways different from these previous finds, particularly due to its sheer size and unexpected trajectory. While other interstellar objects had entered our solar system before, none had displayed such an intricate and seemingly deliberate path, nor had they exhibited such strange characteristics. Despite the object's mysterious nature, the scientific community has been somewhat cautious in its interpretation. Most astronomers have been quick to reject the idea that 3I-ATLAS is anything other than a natural object, offering alternative hypotheses about its origins and behavior. According to some experts, 3I-ATLAS could be a large interstellar comet that, like other comets, is simply passing through our solar system on a trajectory influenced by the gravitational pull of the Sun and other celestial bodies. The lack of typical cometary activity, such as the release of gas and the formation of a tail, could be explained by the object's large size and its position within our solar system. Comets that are far from the Sun may not produce the characteristic outgassing effects, especially if they are composed of materials that are resistant to such processes. However, even the most natural explanations don't fully account for the object's highly unusual behavior. As it passed through our solar system, 3I-ATLAS demonstrated an uncanny ability to navigate its surroundings, dodging large gravitational bodies like Jupiter, Earth, and even the Sun itself. For many, this unusual and precise trajectory raises a compelling question. Could this behavior be purely the result of natural forces, or could it be intentional? One explanation might be that 3I-ATLAS is not a comet at all, but instead a massive artificially designed object, possibly a probe, sent with the intention of silently observing our solar system and its inhabitants. While the idea of alien probes is often treated as speculative or even fringe by many in the scientific community, it has gained more credibility in recent years, especially following the discovery of objects like ʻOumuamua. The mysterious nature of ʻOumuamua, which exhibited unusual acceleration and unexplained changes in speed, led some prominent scientists, including Harvard astrophysicist Dr. Abraham Loeb, to propose that it might have been an artificial object rather than a natural one. Loeb's ideas about ʻOumuamua, which were met with skepticism by some, helped open the door to more discussions about the possibility of extraterrestrial probes visiting our solar system. The introduction of 3I-ATLAS into this conversation is timely, as it shares many characteristics with ʻOumuamua, particularly in terms of its strange trajectory and the lack of observable cometary activity. So, what's the evidence suggesting that 3I-ATLAS could be an alien probe? First, let's consider its behavior. As mentioned earlier, 3I-ATLAS exhibited an unusual retrograde orbit, which means it was moving in the opposite direction of most objects in our solar system. This in itself is an anomaly, as most objects entering our solar system from interstellar space are expected to be gravitationally bound by the Sun and move in the same direction as other objects orbiting the Sun. The fact that 3I-ATLAS was moving in the opposite direction of the majority of solar system objects could indicate that it was purposefully avoiding gravitational interactions or steering itself in such a way as to pass through our solar system without being pulled off course. Furthermore, 3I-ATLAS passed incredibly close to several key planetary bodies, including Mars, Earth, and Jupiter. This is highly unusual, as most objects of this size would be affected by the gravitational forces of these planets, which would alter their trajectory. In most cases, comets or asteroids that enter our solar system from interstellar space are significantly deflected by large bodies like Jupiter or Earth. Yet, 3I-ATLAS seemed to avoid these gravitational wells with remarkable precision. This behavior suggests that 3I-ATLAS may have been deliberately navigating through the solar system, avoiding gravitational interactions and following a predetermined path. This raises the intriguing possibility that 3I-ATLAS is not just a random visitor from another star system, but a probe designed to observe and collect data from our solar system, while staying hidden from view. Next, we must consider the object's composition. Unlike typical comets, which release gas and form tails as they approach the Sun, 3I-ATLAS did not exhibit the expected signs of cometary activity. The lack of outgassing is curious, as it's one of the key features that usually helps astronomers identify comets. This anomaly has led some researchers to propose that 3I-ATLAS may not be a comet at all, but rather an artificial object built to resemble a natural one. If it were a probe, its lack of cometary activity could be intentional, designed to keep it hidden and undetected. By remaining inactive, 3I-ATLAS could more effectively blend in with the background noise of cosmic objects, avoiding attention from both astronomers and other potential extraterrestrial observers. Another compelling piece of evidence pointing toward 3I-ATLAS being an alien probe is the object's speed and trajectory. As it entered our solar system, 3I-ATLAS was traveling at incredible speeds, far faster than typical objects that would be expected to enter our solar system from interstellar space. This high velocity may suggest that it was intentionally propelled at such speeds, either by its creators or by advanced technology on board. Moreover, the fact that 3I-ATLAS was able to traverse such vast distances without suffering significant degradation suggests that it is made of materials that are incredibly resilient to the harsh conditions of space. This level of durability, coupled with its advanced trajectory, points to the possibility that it is a machine designed for long-term exploration and data gathering, not just a random interstellar object. Lastly, we must consider the broader implications of 3I-ATLAS's presence in our solar system. If 3I-ATLAS is indeed an alien probe, it could be the first tangible evidence that we are not alone in the universe. Its deliberate trajectory, unusual composition, and lack of cometary activity make it a perfect candidate for further investigation. If its mission is to observe Earth, it could be the precursor to direct contact with an advanced civilization, or perhaps the first step in a much larger plan of exploration and surveillance by extraterrestrial intelligence. The discovery of 3I-ATLAS could mark the beginning of a new era in human understanding of the cosmos and our place within it. Whether 3I-ATLAS is an alien probe or a natural object, its discovery has undoubtedly sparked a new wave of interest and curiosity about the possibility of extraterrestrial intelligence. The questions it raises about the nature of interstellar objects, the potential for alien life, and the role of advanced technology in space exploration are just the beginning of what could be a transformative moment in our search for answers about the universe. As scientists continue to study 3I-ATLAS, we may eventually learn more about its true nature. Until then, the object remains one of the most fascinating and mysterious visitors to ever grace our solar system. And as we observe its journey, we can only wonder, is this the first of many? Or is 3I-ATLAS a one-time anomaly, a solitary visitor from the stars, sent with a purpose we have yet to fully understand? As we continue to explore the mystery of 3I-ATLAS, one of the most puzzling aspects of this interstellar object is its lack of cometary activity, a behavior that has completely baffled scientists. The absence of the typical outgassing and tail formation that we would expect from a comet challenges our understanding of the object, raising important questions about its nature. This anomaly has been one of the key reasons why many researchers have turned to the hypothesis that 3I-ATLAS could be something more than just a random space rock, perhaps an alien probe or some other form of artificial object. So why has 3I-ATLAS defied expectations and failed to exhibit the usual signs of cometary activity? Let's take a closer look at the possible reasons behind this and what it could mean for our understanding of the object itself. To understand why the lack of cometary activity in 3I-ATLAS is so significant, it's important to first grasp the typical characteristics of a comet. Comets are often referred to as dirty snowballs because they are composed mostly of water ice, dust, and other volatile compounds. As a comet approaches the sun, the heat causes the ices to vaporize, releasing gases and dust particles into space. This outgassing forms a glowing tail that always points away from the sun due to the pressure exerted by sunlight. This behavior has been well documented for centuries and serves as one of the primary methods for astronomers to identify comets as they travel through our solar system. Now, when it comes to 3I-ATLAS, this predictable behavior simply doesn't apply. Even though the object passed close to the sun, where the heat would typically trigger the outgassing process, no visible tail or outgassing was detected. In fact, 3I-ATLAS seemed almost too stable as it moved through our solar system, lacking the telltale signs of activity that we'd expect from a comet of its size and composition. This is a major anomaly, especially considering its massive size and the close pass to the sun, where we would normally expect the object to exhibit some form of cometary behavior. So, what could explain this absence of typical cometary activity? There are several potential explanations, both natural and artificial, that could account for this strange behavior. Let's start by considering natural causes before moving into the more speculative ideas surrounding 3I-ATLAS. One potential natural explanation for the lack of outgassing could be related to cosmic radiation. Space is filled with high-energy radiation that can gradually strip away the volatile components of objects like comets. Over time, the outer layers of comets can be eroded by cosmic rays, which may make it harder for them to release gases in the same way that younger, less exposed comets do. In the case of 3I/ATLAS, it's possible that its prolonged exposure to cosmic radiation has altered its surface, making it less reactive to the heat of the sun. The surface of the object could have become more resistant to heating, preventing the water ice from sublimating into gas. Another factor that could contribute to the lack of cometary activity is the possibility that 3I/ATLAS has been in space for such a long time that its volatile materials have already been exhausted. Over billions of years of interstellar travel, it's conceivable that the ices and gases that would typically form a comet's tail could have been depleted or frozen into the object's interior. This would mean that 3I/ATLAS simply doesn't have enough volatile material left to exhibit the outgassing we expect from other comets. In this scenario, 3I/ATLAS could be an ancient relic, traveling through the void of space, its surface worn down and its volatile compounds mostly gone. This would explain why it's not producing the characteristic outgassing behavior seen in newer comets. Another possible explanation could lie in the specific composition of 3I/ATLAS. Scientists have found that it is made up of a combination of water ice and organic compounds, which are ingredients commonly associated with the formation of life. The question is, could these components be chemically different from those found in regular comets, possibly making the object more stable than expected? For instance, 3I/ATLAS could be composed of a particularly dense form of ice, or a layer of material that prevents the typical sublimation process when it encounters heat. This would mean that even as the object passed close to the sun, the heat might not have been sufficient to cause the usual outgassing. The ice might have been too tightly bound to the object's core, or could have been shielded by a layer of organic compounds that prevented it from vaporizing. Some researchers have speculated that 3I/ATLAS might not be a comet at all, but something else entirely. Could it be that what we are observing is not a simple icy body but something more complex? Perhaps 3I/ATLAS is a more solid, asteroid-like object with a surface layer of chemicals that does not behave like a typical comet. The absence of a tail and lack of gas emissions could indicate that the object has a more rigid structure than expected, making it resistant to the typical processes that cause comets to lose material. While natural explanations could account for the lack of cometary activity in 3I/ATLAS, the more speculative possibility is that the object is not a natural comet at all, but rather an artificial object, perhaps an alien probe designed to avoid detection. The hypothesis that 3I/ATLAS could be an extraterrestrial probe fits neatly with the object's lack of outgassing. In this case, the absence of cometary activity might not be a mere coincidence. It could be a deliberate feature of its design. If 3I/ATLAS is an alien probe, one of its key features might be its ability to remain undetected. For an object designed to gather information about Earth or our solar system without being noticed, emitting gases and forming a tail would be counterproductive. The very presence of a visible tail or cometary activity would make it obvious to astronomers and other observers, revealing its true nature. By remaining inactive and blending in with other natural objects, 3I/ATLAS could carry out its mission of surveillance or data gathering without alerting us to its presence. In this case, the lack of a tail could be a sign of advanced technology. Perhaps the probe is using a form of camouflage, either through the manipulation of its surface to resist heating, or by some form of energy shield that prevents the release of gas. If 3I/ATLAS is indeed an extraterrestrial probe, its lack of typical cometary features could be an intentional design feature, allowing it to function as a stealth surveillance device. The object's lack of outgassing could be a way to preserve its secrecy, while still fulfilling its mission of observation. If 3I/ATLAS were an artificial object, one of the most intriguing possibilities is that it could be powered by solar radiation or some other form of advanced energy. We know that even in the cold reaches of interstellar space, energy is still present in the form of cosmic radiation, starlight, and other energetic particles. It's possible that the object is to harness this energy without the need for outgassing or traditional propulsion systems, such as the ones seen in conventional spacecraft. Instead of relying on volatile materials like comets do, an alien probe like 3I/ATLAS might be self-sustaining, collecting energy in a way that prevents the need for outgassing. In this case, the lack of cometary behavior would be a key feature, as it would suggest that 3I/ATLAS is not a traditional comet or even an asteroid, but something more sophisticated. The very fact that 3I-ATLAS has evaded all the traditional signs of natural cometary activity could be one of the clearest indications that it is far more than just a simple object traveling through space. The absence of cometary activity in 3I-ATLAS presents a major puzzle, but it also has profound implications for the broader search for extraterrestrial life. If 3I-ATLAS is indeed an artificial probe, it could be the first tangible evidence of extraterrestrial intelligence, an interstellar mission sent by an advanced civilization to study Earth and its inhabitants. This raises the possibility that we are not alone in the universe, and that other civilizations have already ventured out into space, silently observing us from afar. If we can confirm that 3I-ATLAS is an alien probe, it would represent one of the most significant discoveries in the history of humankind, opening up a new chapter in our search for life beyond Earth. As scientists continue to study 3I-ATLAS, we are left to wonder whether this object is the first of many alien probes to pass through our solar system, or whether it is a unique anomaly. The lack of typical cometary activity is a mystery that will continue to fascinate astronomers and researchers. Whether it is a natural object or an artificial probe, 3I-ATLAS has already begun to change the way we think about the universe and our place in it. As 3I-ATLAS continues its journey through our solar system, one of the most fascinating aspects of this object is the continued mystery surrounding its lack of typical cometary activity. Comets, as we know them, are characterized by their brilliant tails formed when ice and other volatile materials vaporize as the object gets closer to the Sun. However, 3I-ATLAS has not shown any of these expected behaviors. Its movement through the solar system, its composition and especially the absence of cometary features raise several important questions that have not only sparked scientific debate, but also fueled speculation about the true nature of this object. Why has 3I-ATLAS failed to behave like a typical comet? And what could its lack of outgassing mean for our understanding of this mysterious interstellar traveler? To fully grasp why the lack of cometary activity in 3I-ATLAS is so puzzling, it's important to understand what we would typically expect from a comet passing through the solar system. Comets are primarily composed of water ice, dust, and other volatile compounds. As a comet approaches the Sun, the heat causes these materials to vaporize, releasing gas and forming a tail. This tail, which is always directed away from the Sun due to the pressure of sunlight, is one of the most distinguishing features of a comet. The formation of a tail is a natural consequence of the Sun's heat interacting with the volatile materials on the surface of the comet. In addition to the tail, comets often emit a variety of gases, such as carbon dioxide, water vapor, and methane. These gases are released as the comet heats up, and the material in the tail consists of both gas and dust particles that have been ejected from the comet's nucleus. This process is known as outgassing, and it is what gives comets their characteristic appearance. As a result, when an object like 3I-ATLAS passes close to the Sun, scientists expect to see some form of tail or outgassing, just as we've observed in countless other comets. However, 3I-ATLAS defied all expectations by showing no sign of a tail or any visible outgassing, leaving scientists with more questions than answers. The most glaring anomaly with 3I-ATLAS is the complete absence of the typical cometary features that we've come to associate with interstellar objects. Despite its massive size and close pass by the Sun, the object has shown no signs of the outgassing we would normally expect from an object composed of ice and other volatile compounds. If 3I-ATLAS were a comet, the heat from the Sun should have caused it to release gases and form a bright tail. Yet, despite passing through regions of space where we typically see these effects, no such activity has been observed. This lack of cometary behavior presents a significant puzzle. Even comets that pass through the outer reaches of our solar system, far from the Sun, typically show some signs of activity. Yet 3I-ATLAS, despite its proximity to the Sun, behaves as if it is immune to the expected processes that would typically trigger its outgassing. Could there be something fundamentally different about this object that prevents it from behaving like a typical comet? Or is there another explanation entirely? There are several potential natural explanations that could account for the lack of outgassing in 3I-ATLAS. One possibility is that the object's surface composition is fundamentally different from that of a typical comet. For instance, if the 3I-ATLAS object contains a layer of material that is particularly resistant to sublimation, the process by which a solid turns directly into a gas, it might not release gases when it heats up. The surface could be made of a more solid or dense material that requires much higher temperatures to release any volatile compounds. Additionally, 3I-ATLAS may have been in space for billions of years, during which time the volatile compounds that are typically found on comets might have already been exhausted or frozen deep into its interior. Comets are often considered to be dirty snowballs made of water ice, methane, ammonia, and other volatile compounds. Over time, as these materials are exposed to the vacuum and radiation of space, they can be slowly depleted. In fact, objects like 3I-ATLAS, which have been traveling through interstellar space for such an extended period, may have had their volatile materials stripped away or altered by cosmic radiation long before they entered our solar system. This depletion could account for the lack of outgassing, as there simply might not be enough volatile material left on the surface to create the typical tail that comets are known for. Another possible explanation lies in the environment that 3I-ATLAS has traveled through during its journey. While interstellar space is cold and hostile, it is not entirely empty. The object could have passed through regions of space where it encountered intense radiation, dust, or other environmental factors that altered its surface properties. Such conditions could have caused the ice on its surface to become more solid or embedded within the object's structure, making it less susceptible to vaporization. This could explain why 3I-ATLAS did not exhibit typical cometary behavior despite being so close to the Sun. Its surface could have been altered by its prolonged exposure to the harsh conditions of deep space, preventing it from releasing gases even as it passed by the Sun. While natural explanations provide some insight into the lack of cometary activity in 3I-ATLAS, there is another, far more speculative hypothesis. What if 3I-ATLAS is not a natural object at all, but instead an alien probe? Could the object's lack of outgassing be a sign that it is not a comet, but an artificial, highly sophisticated piece of technology designed to avoid detection? The idea that 3I-ATLAS might be an alien probe has been proposed by several scientists, particularly in light of the object's peculiar trajectory and its behavior as it passed through our solar system. If 3I-ATLAS were intentionally designed as a probe, it would make sense for it to remain hidden and inactive, avoiding any behaviors that would alert us to its true nature. The lack of cometary activity could then be seen as a feature, not a flaw, of the probe's design. Instead of exhibiting the usual outgassing associated with comets, the probe could have been engineered to avoid detection by remaining completely silent and undisturbed. In this scenario, the absence of a tail, or outgassing, might suggest a high degree of technological sophistication. The creators of 3I-ATLAS might have built it with the purpose of observing us from a distance, without drawing attention to itself. This would be consistent with the idea of the dark forest theory, which posits that intelligent civilizations in the universe may intentionally remain hidden to avoid being destroyed by more advanced civilizations. If 3I-ATLAS is a probe sent by an alien civilization, it may be gathering data about Earth while carefully avoiding any actions that would reveal its presence. The absence of cometary activity could be one way that it stays under the radar, operating without being detected by Earth-based astronomers or other spacefaring civilizations. The probe hypothesis is further supported by the fact that 3I-ATLAS was able to travel through the solar system without being significantly affected by gravitational forces from planets like Jupiter or Earth. Its path seemed calculated, as though it was deliberately avoiding these large bodies. If it were an alien probe, its trajectory could have been planned to ensure that it passed close enough to Earth to collect data without being disrupted by gravitational interactions. The lack of a tail could also be a design feature, allowing the object to pass through the solar system without leaving behind any obvious signs of its presence. If 3I-ATLAS is indeed an alien probe, it would represent one of the most significant discoveries in the history of humankind. The implications of such a finding are profound, as it would provide direct evidence of extraterrestrial intelligence and technological prowess. The discovery of a probe, an artificial object sent from another star system, would radically alter our understanding of the universe and humanity's place within it. It would suggest that intelligent civilizations exist beyond Earth and that they are capable of interstellar travel and exploration. The possibility that 3I-ATLAS is an alien probe also raises important questions about the nature of extraterrestrial life. If advanced civilizations are capable of building probes to observe other star systems, how many such probes might be out there silently watching us from the dark corners of the galaxy? Could 3I-ATLAS be just the first of many probes sent by an advanced civilization, perhaps part of a larger network of surveillance missions designed to monitor planets like Earth? And if 3I-ATLAS is indeed an alien artifact, what might its creators hope to learn from us, and what will happen if we do eventually make contact? In the broader search for extraterrestrial life, the discovery of 3I-ATLAS, whether it is a natural object or an alien probe, represents a major milestone It forces us to reconsider our assumptions about the universe, our place in it, and the potential for intelligent life elsewhere. The mystery surrounding 3I-ATLAS may be far from solved, but its presence in our solar system serves as a powerful reminder that we are not alone in the vast expanse of the cosmos. The search for answers continues, and 3I-ATLAS may just be the key to unlocking one of the greatest mysteries in human history, the existence of extraterrestrial intelligence. The lack of typical cometary behavior exhibited by 3I-ATLAS is one of the most perplexing aspects of this interstellar object. Comets, which are often composed of ice, dust, and other volatile materials, traditionally display a distinct set of behaviors as they approach the Sun. They heat up, releasing gases and dust that form a glowing tail, a signature feature that astronomers rely on to identify them as comets. Yet 3I-ATLAS has shown no signs of this typical outgassing, despite its passage through the solar system and its close proximity to the Sun. This strange absence of cometary activity has caused a stir among scientists, raising intriguing questions about the nature of 3I-ATLAS. Is it truly a comet, or could it be something else entirely? Let's explore the possible reasons behind this anomaly and what it might mean for our understanding of this mysterious object. When a comet enters the solar system, it typically begins to heat up as it gets closer to the Sun. This heat causes the volatile materials on its surface, such as water ice, methane, and carbon dioxide, to vaporize, creating a cloud of gas and dust around the nucleus. This cloud, called a coma, can sometimes be seen as a glowing halo around the nucleus, while the solar wind pushes the gas and dust away from the Sun, forming the comet's characteristic tail. The presence of this tail is one of the key ways that astronomers can identify a comet and differentiate it from other objects in the solar system, such as asteroids. The tail always points away from the Sun, a feature caused by the pressure exerted on the gases and dust by sunlight. In the case of 3I-ATLAS, however, no such tail has been observed. Despite its close encounter with the Sun and the expected heating effect that would normally trigger cometary outgassing, 3I-ATLAS has remained unusually inert. No coma has formed around it, and no gas emissions have been detected. This lack of expected cometary behavior is the central mystery surrounding 3I-ATLAS, and has raised several questions about its nature. Is it truly a comet, or is it something entirely different? There are a few potential natural explanations for why 3I-ATLAS might not be exhibiting the expected cometary behavior. The first and most obvious possibility is that 3I-ATLAS might not be a typical comet at all. While most comets are composed primarily of ice and dust, it's possible that 3I-ATLAS is made up of different materials that do not readily sublimate when exposed to the heat of the Sun. For example, it could be an asteroid or a different type of icy body that does not contain the same volatile compounds found in comets. If 3I-ATLAS has a much denser or more solid surface than typical comets, it may not have the same volatile materials that would typically create the characteristic outgassing. This would explain the lack of a tail and the absence of observable gas emission. Moreover, 3I-ATLAS has been traveling through space for a significant amount of time, likely billions of years. During this long journey, it could have been exposed to cosmic radiation and other environmental factors that may have altered its surface and its composition. Over such a long period of time, the volatile materials in the object's composition could have been depleted or altered by radiation, preventing the object from exhibiting the typical behaviors we would expect from a comet. The solar wind, cosmic radiation, and the vacuum of space may have eroded the surface and removed the materials that would normally sublimate and form a tail. Another possibility is that 3I-ATLAS could be made of materials that are particularly resistant to sublimation. Sublimation is the process by which a solid turns directly into a gas without first becoming a liquid, and it is responsible for the outgassing we see in comets. However, some materials may require higher temperatures or more intense radiation to sublimate than others. It's possible that the composition of 3I-ATLAS includes such materials, which would make it less prone to the usual cometary activity. The object's surface could be composed of a thick insulating layer that prevents heat from reaching the volatile materials inside, keeping them from vaporizing. If this is the case, 3I-ATLAS would not behave like a typical comet, and its lack of outgassing would simply be the result of its unique material composition. While natural explanations are plausible, they do not fully account for the striking lack of cometary behavior observed in 3I-ATLAS. The absence of outgassing, coupled with the object's precise and seemingly deliberate trajectory, has led some to propose a more speculative, yet equally intriguing possibility that 3I-ATLAS is not a natural object at all, but an alien probe. The idea that 3IATLAS could be an artificial object sent by an extraterrestrial civilization has been gaining traction, particularly in light of its strange characteristics and its apparent disregard for typical cometary behavior. If 3IATLAS is an alien probe, its lack of outgassing could be a deliberate feature of its design. One of the key goals of a probe, particularly one that is designed to operate over long distances and long periods of time, would be to avoid detection. Outgassing, which creates a visible tail, could reveal the presence of the object, making it easier to spot from Earth or other civilizations. In order to stay undetected, an alien probe like 3IATLAS might have been engineered to remain inactive without the typical release of gas that would make it visible to observers. Moreover, the probe hypothesis fits well with the object's unusual trajectory. 3IATLAS entered the solar system on a retrograde orbit, which is not typical for objects coming from interstellar space. Instead of following the predictable paths that most comets or asteroids would follow under the influence of the sun's gravity, 3IATLAS appeared to be navigating the solar system with unusual precision. This deliberate trajectory, combined with the lack of outgassing, strongly suggests that 3IATLAS might not be a random object passing through our solar system, but a probe sent with a specific purpose to observe and perhaps collect data on Earth and its environment. If 3IATLAS is indeed an alien probe, the question remains, why would an advanced civilization send a probe to our solar system, and why would it avoid interacting with us? To answer this question, we must turn to the dark forest theory, a concept that has gained attention in the search for extraterrestrial intelligence. The theory, popularized by Chinese science fiction author Liu Cixin in the Three-Body Problem series, proposes that the universe is like a dark forest, where every civilization is a hunter trying to survive. In this metaphorical forest, each civilization remains hidden to avoid detection by others, as revealing one's position could lead to annihilation by a more advanced civilization. The dark forest theory suggests that the safest strategy for any civilization is to stay silent and undetected, which could explain why extraterrestrial probes might avoid making their presence known. If 3IATLAS is a probe sent by an alien civilization, its stealthy approach could be explained by the dark forest theory. The creators of the probe may have intentionally designed it to remain undetected in order to avoid alerting other, possibly more advanced civilizations to their existence. By remaining inactive, 3IATLAS would be able to carry out its mission of observation without making itself known. This approach would fit perfectly with the notion that advanced civilizations, once they reach the capability to explore the stars, might choose to observe other civilizations without making contact, ensuring their own survival by staying hidden. The discovery of 3IATLAS, whether it is a natural object or an artificial probe, has profound implications for the search for extraterrestrial life. If this object is indeed an alien probe, it would be the first direct evidence of an intelligent extraterrestrial civilization capable of interstellar travel. This discovery would challenge everything we thought we knew about life in the universe, opening up new avenues of inquiry and speculation. How many other probes or artifacts might be out there, quietly observing distant civilizations like our own? And if 3IATLAS is an alien probe, what does it mean for humanity's place in the universe? Are we truly alone, or are we just one of many civilizations scattered throughout the stars, waiting to be discovered? In many ways, 3IATLAS is more than just an astronomical phenomenon. It is a reminder that our search for answers about extraterrestrial life is only just beginning. As we continue to study this object, we will gain more insight into its nature, its origins, and its purpose. Whether it is a comet, an asteroid, or a probe sent by an advanced civilization, 3IATLAS holds the potential to revolutionize our understanding of the universe and our place within it. The absence of cometary activity may ultimately be the key to unlocking the mystery of this object, and the answers we find could lead to a new era in the search for life beyond Earth. As we continue to unravel the mystery of 3IATLAS, one of the most tantalizing possibilities is the notion that this interstellar object might be more than just a natural phenomenon. Could 3IATLAS actually be an alien probe, sent across the vastness of space to observe our solar system? The idea of an extraterrestrial probe, quietly observing Earth and its inhabitants, is not just a science fiction fantasy. It's a hypothesis that, though speculative, is now gaining traction in certain circles of the scientific community. The possibility that 3IATLAS might be an artificial object, designed, launched and guided by an advanced civilization, is one of the most provocative explanations for its strange behavior. But how plausible is this idea, and what would it mean for our understanding of the universe? To begin, let's revisit the unusual characteristics of 3I-ATLAS that make the alien probe hypothesis so compelling. First and foremost, there's the object's bizarre trajectory. Unlike other interstellar objects, which typically follow random paths through space, 3I-ATLAS exhibited an almost too precise path through the solar system. The object entered on a retrograde orbit, traveling in the opposite direction of most objects in our solar system. This retrograde motion could suggest that 3I-ATLAS was deliberately steered to avoid gravitational interactions with larger bodies, like the Sun and the planets, in order to stay on a predetermined course. Additionally, the absence of typical cometary behavior, such as the formation of a tail or outgassing as it approached the Sun, adds another layer of mystery. When comets pass close to the Sun, they typically heat up, releasing gases and dust in a spectacular display of outgassing, forming the signature tail that we associate with comets. But 3I-ATLAS exhibited no such activity. Despite being composed of ice and organic compounds, materials that usually sublimate and release gas when exposed to heat, there was no sign of the typical cometary tail or cloud of debris. This lack of expected activity could point to the possibility that 3I-ATLAS is not a comet at all, but a highly sophisticated piece of technology, possibly a probe designed to avoid detection. If 3I-ATLAS is indeed an alien probe, then the question arises, why would an advanced civilization send a probe to our solar system to begin with? The answer may lie in the nature of scientific exploration and the pursuit of knowledge. Just as we send probes to distant planets and moons in our own solar system to learn more about the universe, it's entirely possible that an advanced civilization might send out probes to explore other star systems, looking for signs of life or simply conducting reconnaissance. One possible reason for sending a probe to Earth could be the desire to observe and gather data on an inhabited planet. Earth, with its unique blend of life forms and ecosystems, would be an intriguing object of study for any civilization capable of interstellar travel. Perhaps the creators of 3I-ATLAS were interested in studying the diversity of life on Earth, understanding our atmosphere, our technological development, and even our behavior as a species. The object's trajectory, which passed relatively close to Earth and the other planets, could suggest that it was intentionally gathering data, perhaps to assess the potential for contact or study the development of intelligent life. Another theory could be that 3I-ATLAS was sent as part of a broader interstellar exploration mission, perhaps to learn about the conditions in other solar systems, and to track the development of life on various planets. Just as we study distant exoplanets in search of habitable environments, an advanced extraterrestrial civilization might be conducting similar research across the galaxy. The probe might have been designed to visit a variety of star systems, collecting data without revealing its presence, using a trajectory that avoids disrupting the balance of local gravitational forces or attracting attention. Yet another possibility is that 3I-ATLAS could be an early warning system or part of a larger network of probes sent to monitor potential threats across the galaxy. The idea that extraterrestrial civilizations could have developed probes to monitor the cosmos for signs of danger or potential threats is a concept that has been explored in both science fiction and scientific speculation. Perhaps the creators of 3I-ATLAS were part of a larger cosmic network where probes are distributed across the galaxy to detect the rise of new civilizations or to identify any potential threats from other intelligent species. If 3I-ATLAS is an alien probe, it would likely have to be an extraordinarily advanced piece of technology. The idea of a probe traveling across interstellar distances for potentially millions or even billions of years presents significant technological challenges. How could a probe like 3I-ATLAS sustain itself over such an extended period? What kind of power source would it use to remain functional as it traveled through the harsh vacuum of space? One of the most plausible explanations for the longevity of 3I-ATLAS is that it could be powered by solar radiation or some form of radioactive decay. For an object to survive the cold void of interstellar space for such an extended period, it would need an incredibly efficient and reliable power source. Solar energy might seem unlikely at first, since 3I-ATLAS is so far from any star, but it's important to remember that even in the cold reaches of space, there are still sources of radiation that could provide energy to a self-sustaining probe. The materials used in the construction of 3I-ATLAS could be designed to harvest energy from cosmic radiation, starlight, or other ambient sources. Additionally, 3I-ATLAS could have been equipped with advanced self-repair mechanisms. Just as modern spacecraft are designed with redundant systems to ensure continued functionality, an alien probe would likely need to be able to repair itself or at least maintain its basic operations over time. The possibility of advanced nanotechnology or robotic systems capable of self-repair is not beyond the realm of imagination. Such a system could enable the probe to endure for eons, making minor repairs and adjustments to its systems as needed, ensuring that it continues to operate effectively long after its creators are gone. The durability of 3IATLAS also suggests that it might be made from advanced materials that are highly resistant to the harsh conditions of space. If it were a piece of alien technology, the materials used to construct it would likely be designed to withstand the extreme temperatures, cosmic radiation, and other challenges posed by interstellar travel. Unlike objects like comets, which are relatively fragile and can degrade over time, an alien probe like 3IATLAS would need to be built to endure the void of space for long periods without succumbing to wear and tear. One of the most compelling aspects of the theory that 3IATLAS is an alien probe is the idea that it might have been designed to operate covertly. If it is an advanced piece of technology sent to observe our solar system, its creators would likely want it to remain undetected for as long as possible. The lack of cometary activity, the absence of a tail or outgassing, could be seen as a deliberate design feature to keep the probe hidden. In many ways, the behavior of 3IATLAS mirrors what we might expect from a spacecraft designed to observe a planet without revealing its presence. A probe that emits no signals or noticeable features would be far less likely to attract attention, whether from humans, other civilizations, or even cosmic phenomena. The idea that 3IATLAS is silent and inactive could be part of a broader strategy of avoiding detection, operating as a stealth mission to observe Earth without revealing itself to the inhabitants of our planet. If 3IATLAS is indeed a probe, its creators may have intentionally built it to be as inconspicuous as possible, avoiding the telltale signs of activity that would normally make a comet or spacecraft visible. In this case, the lack of a visible tail or gas emissions is not an oversight, but rather a carefully designed feature to ensure that the probe could observe its target, Earth, without alerting anyone to its presence. The possibility that 3IATLAS is an alien probe has far-reaching implications for humanity. If this object is indeed a piece of extraterrestrial technology, it would be the first tangible evidence that we are not alone in the universe. The discovery of 3IATLAS could be the catalyst for a paradigm shift in our understanding of life in the cosmos. It would not only validate the hypothesis that intelligent extraterrestrial civilizations exist, but it would also open the door to new questions about the nature of these civilizations and their motives. If 3IATLAS is a probe designed to monitor Earth, then we might be on the verge of discovering the first concrete evidence of an alien intelligence. This discovery would force us to reconsider everything we know about our place in the universe. Are we truly the only intelligent beings in the cosmos? Or is Earth just one of many worlds under observation by extraterrestrial civilizations? What might we learn from the data gathered by 3IATLAS? And most importantly, what happens if we make contact with the civilization that sent it? Whether or not 3IATLAS is an alien probe, the questions it raises about the potential for extraterrestrial life and intelligence are profound. The object's journey through our solar system has sparked renewed interest in the search for extraterrestrial intelligence, SETI, and has given us a glimpse into a future where humanity may no longer be alone in the universe. As we continue to study 3IATLAS and its strange behavior, one thing is certain: the quest for knowledge about our cosmic neighbors is far from over, and the mystery of 3IATLAS is only the beginning of a much larger story. As the mystery of 3IATLAS continues to captivate scientists, astronomers, and the public alike, we are left to wonder what the true significance of this interstellar object might be. Whether it is a natural object or an alien probe, the presence of 3IATLAS in our solar system raises important questions about the nature of life, intelligence, and exploration in the universe. As we delve deeper into the investigation of this object, it becomes increasingly clear that its discovery has broader implications for humanity's place in the cosmos and the future of interstellar exploration. The possibility that 3IATLAS could be an alien probe sent to observe Earth touches on one of the most profound questions humanity has asked for centuries. Are we alone in the universe? For decades, scientists have searched for signs of extraterrestrial life, from radio signals to the exploration of distant planets. The discovery of 3IATLAS, an object that behaves in ways we do not fully understand, offers tantalizing possibilities that we may not be alone after all. This is not the first time humanity has looked to the stars for answers, but 3IATLAS represents a new chapter in this search. If it is a probe sent by an advanced extraterrestrial civilization, it would be the first direct evidence of intelligent life beyond Earth. The search for extraterrestrial intelligence, SETI, has been a cornerstone of scientific inquiry for decades, from the pioneering efforts of Frank Drake in the 1960s with the development of the Drake equation, to the more recent endeavors like the Breakthrough Listen initiative. Scientists have been listening for signals from alien civilizations for years. However, the discovery of 3IATLAS presents a new avenue for exploration. Instead of waiting for a direct message from alien civilizations, we may have already encountered a physical object that could serve as a silent witness to the existence of other life in the galaxy. What makes the possibility of 3IATLAS being an alien probe so intriguing is not just its unusual behavior, but also its apparent age. If 3IATLAS has been traveling through space for billions of years, it could be a relic from an ancient civilization that predates our own. This opens up entirely new possibilities for understanding the timeline of intelligent life in the universe. Could this object be the result of a long-gone civilization that once thrived in another star system, leaving behind a probe to observe distant worlds? The idea that extraterrestrial life may have existed long before humanity, with the remnants of their technology still drifting through space, is a concept that challenges our very understanding of time and evolution in the cosmos. Regardless of whether 3IATLAS is an alien probe or a natural object, its discovery signals a pivotal moment in the history of space exploration. Interstellar travel and the exploration of other star systems are currently beyond our technological capabilities, but the presence of an interstellar object in our solar system offers a glimpse into the possibility of exploring the stars. If an object like 3IATLAS can travel across vast distances between stars, then it suggests that such journeys are in theory possible. While the technology required to send a probe like 3IATLAS to our solar system may be far beyond anything we can currently conceive, its existence provides proof that interstellar exploration is not purely science fiction. One of the most exciting aspects of studying 3IATLAS is the potential to learn from its structure, composition, and trajectory. If 3IATLAS is a probe, it could be equipped with technology that allows it to survive for billions of years without decaying or losing functionality. The ability to design an object that can withstand the harsh conditions of space, including radiation, temperature fluctuations, and micrometeorite impacts, would require advanced engineering techniques. Studying the materials and technologies used in the construction of 3IATLAS could provide invaluable insights into how we might one day design our own interstellar probes for future missions. By reverse engineering or drawing inspiration from the probe's features, humanity could unlock the secrets to long-duration space travel and create the tools necessary to explore other star systems. The possibility of extraterrestrial life is one that has captivated humanity for centuries, and the discovery of 3IATLAS offers the tantalizing prospect that contact with intelligent beings from another star system may be closer than we think. But if 3IATLAS is an alien probe, the question remains, what happens next? Could this be the beginning of a larger interaction with extraterrestrial civilizations, or is this simply the first of many probes sent out by a distant civilization to study our solar system? One possibility is that 3IATLAS is part of a larger network of probes, each sent to different star systems to gather information about the conditions in the galaxy. If this is the case, then the discovery of 3IATLAS may be the beginning of a series of encounters with alien probes over the coming years. This could open up entirely new areas of scientific exploration and collaboration. In a future where humanity is capable of reaching out to the stars, the presence of alien probes could serve as a bridge to contact with extraterrestrial civilization. Perhaps these probes are not meant to make contact directly, but rather to observe and collect data about the planets they visit, offering a way for alien civilizations to learn about us without revealing their own existence. Another possibility is that 3IATLAS is a one-time visitor, a solitary probe sent from a civilization that no longer exists. In this case, 3IATLAS could be a silent witness to an ancient and long-dead civilization, slowly drifting through the vast reaches of space long after its creators have disappeared. This raises profound questions about the lifespan of intelligent civilizations in the universe. If an advanced civilization is capable of sending probes across interstellar distances, how long does that civilization survive? Do they leave behind traces of their technology, as we are seeing with 3IATLAS, or do they disappear without a trace, their existence lost to the void of space? Regardless of whether 3IATLAS is a natural object or an alien probe, its discovery serves as a wake-up call for humanity. It reminds us of the vastness of the universe and the possibility that we are not as alone as we once thought. For centuries, humanity has gazed up at the stars, wondering if we are the only intelligent life in the cosmos. Now with 3IATLAS passing through our solar system, we are confronted with the possibility that we are just one of many civilizations, each of us a small part of a much larger cosmic story. The discovery of 3I-ATLAS also underscores the importance of continuing to explore space. The study of interstellar objects, the development of new space technologies, and the ongoing search for extraterrestrial life are all crucial steps in understanding our place in the universe. As we advance in our ability to explore space, we are opening up new frontiers for scientific discovery and potentially for contact with other civilizations. The quest for knowledge is a fundamental part of the human spirit, and as we learn more about objects like 3I-ATLAS, we are inching closer to the answers to some of the most profound questions humanity has ever asked. The discovery of 3I-ATLAS is not just a scientific curiosity, it is a milestone in our journey to understand the universe. Whether it is a natural object or an alien probe, the presence of 3I-ATLAS in our solar system raises important questions about life, intelligence, and exploration beyond Earth. Its unusual trajectory, composition, and behavior challenge our assumptions about what we know about space and interstellar travel, pushing the boundaries of our understanding of the cosmos. As we continue to study 3I-ATLAS, we are not just investigating a single object, but taking the first steps in a much larger quest to understand the nature of life in the universe. The search for extraterrestrial intelligence, the study of interstellar objects, and the exploration of distant star systems are all interconnected parts of humanity's ongoing exploration of the unknown. With each new discovery, we move closer to understanding the mysteries of the universe, and perhaps closer to making contact with other civilizations that may be watching us from the stars. The journey is just beginning, and 3I-ATLAS is a reminder of how much we have yet to discover. As 3I-ATLAS continues its journey through our solar system, it has already made a significant impact on the scientific community, sparking debates, fueling curiosity, and challenging our understanding of the universe. Whether it's a natural interstellar object or an alien probe, its existence raises fundamental questions about the nature of life, intelligence, and exploration beyond our planet. The questions that 3I-ATLAS poses about our place in the cosmos, the possibility of extraterrestrial life, and the future of space exploration are profound, and the answers we uncover may shape the trajectory of humanity for generations to come. The discovery of 3I-ATLAS has already begun to push the boundaries of what we understand about the universe. While it's been known for some time that objects can travel between star systems, such as comets and asteroids entering our solar system, the scale of 3I-ATLAS, coupled with its peculiar characteristics, has raised the stakes. Its size, estimated to be far larger than other interstellar objects like ʻOumuamua, its strange trajectory, and the absence of typical cometary activity, all point to something unique, something that might not fit the conventional definition of a natural object. This anomaly has forced scientists to rethink their assumptions and consider alternative possibilities, including the radical idea that 3I-ATLAS could be an artificial object, possibly a probe sent by an advanced extraterrestrial civilization. But regardless of whether 3I-ATLAS turns out to be a probe, a natural comet, or something entirely different, its mere presence challenges us to think on a grander scale. The fact that an object from another star system has entered our solar system and has been observed in real time by scientists on Earth serves as a tangible reminder of the vastness of the universe. It brings home the realization that our planet is just a small part of a much larger cosmic tapestry, one that is full of wonders, mysteries, and possibilities. Perhaps the most profound implication of 3I-ATLAS's discovery is the possibility that it could be an alien probe sent by a civilization far more advanced than our own. The idea that we may not be alone in the universe has been a topic of fascination for millennia, but the search for extraterrestrial life has always been speculative. Now, with the discovery of 3I-ATLAS, the possibility that we have encountered alien technology, whether intentional or not, has become much more tangible. If 3I-ATLAS is a probe sent to observe Earth or simply to collect data about our solar system, it would represent the first concrete evidence of intelligent extraterrestrial life. This realization opens up entirely new questions about the nature of life in the universe. If 3I-ATLAS is indeed an alien artifact, what does this tell us about the civilization that created it? What kind of technology did they possess to build a probe capable of traveling across interstellar distances? How advanced are they? And what might their motivations be? These questions have significant implications not only for our understanding of the cosmos, but also for our place in it. For decades, humanity has been listening for signals from alien civilizations, but the discovery of a physical object, an actual probe, would take the search to an entirely new level. It would validate the idea that intelligent life exists beyond Earth and that we may have already encountered traces of it. Moreover, the potential discovery of alien technology raises deeper questions about the future of humanity. If extraterrestrial civilizations have developed the means to travel between stars, what might this mean for the future of interstellar exploration? Are we destined to remain confined to our solar system, or will we one day unlock the secrets of long-distance space travel and join the ranks of those advanced civilizations? The discovery of 3IATLAS could serve as a catalyst for an entirely new era in space exploration, one that brings us closer to understanding the capabilities and motivations of alien civilization. If 3IATLAS is indeed an alien probe, then what happens next? What are the implications of such a discovery for the future of humanity? For one, it could open up the possibility of contact with extraterrestrial intelligence, though not necessarily in the way that many of us might imagine. The probe may not be designed to make direct contact with us. It might simply be a passive observer gathering data from our solar system and sending it back to its creators. However, the very fact that we have encountered this object suggests that at some point we may come into contact with the civilization that sent it. This prospect raises many questions. How will humanity respond to the knowledge that we are not alone in the universe? Will governments, space agencies, and the scientific community collaborate to explore the implications of 3IATLAS's presence in our solar system? Or will the discovery lead to division and fear? The concept of extraterrestrial life, particularly intelligent life, has long been a topic of speculation, but the actual discovery of alien technology could have profound psychological, philosophical, and societal effects. The realization that we are not the only intelligent beings in the universe could change the way we think about ourselves, our place in the cosmos, and our future as a species. If 3IATLAS is a probe sent by an advanced civilization, it could signal the beginning of a new chapter in human history, one where the search for extraterrestrial life moves from speculation to reality. Whether or not this contact results in direct communication, the mere fact that such a probe exists suggests that the cosmos is teeming with possibilities, and that humanity's understanding of life in the universe will be forever transformed. While 3IATLAS's discovery may have been a surprising and serendipitous event, it also underscores the importance of ongoing space exploration. The object was detected by the ATLAS Observatory, part of a global network of telescopes and observatories dedicated to scanning the sky for near-Earth objects, NEOs, asteroids, and other celestial bodies. This type of monitoring is critical for not only identifying potential threats to Earth, but also for discovering and studying objects like 3IATLAS objects that could hold the key to understanding the origins of the solar system and the broader universe. The search for interstellar objects, particularly those that may have traveled from distant star systems, will become increasingly important in the years to come. As technology advances, our ability to detect and study objects like 3IATLAS will improve, giving us greater insight into the behavior and composition of these mysterious visitors. In the case of 3IATLAS, scientists are already using cutting-edge instruments to analyze the object's trajectory, composition, and potential origins. Each new observation adds to our growing understanding of interstellar objects and their role in the broader cosmic environment. In addition to monitoring interstellar objects, space exploration missions aimed at studying exoplanets, distant stars, and other solar systems will help us learn more about the conditions that give rise to life. The discovery of 3IATLAS could be just the tip of the iceberg when it comes to exploring the universe for signs of life. As humanity continues to advance in its ability to explore space, we may one day find ourselves not just detecting distant objects, but actively reaching out to explore new star systems, potentially making contact with other intelligent civilizations. Ultimately, the discovery of 3IATLAS forces us to confront some of the most profound questions about the nature of the universe. It challenges our assumptions about the uniqueness of Earth and the possibility of life beyond our planet. Whether 3IATLAS is a natural object or an alien probe, its presence in our solar system is a reminder that the universe is vast, full of wonders, and full of unknowns. For centuries, humanity has looked up at the stars, wondering whether we are the only intelligent beings in the universe. Now, with 3IATLAS passing through our solar system, we may be on the verge of answering that question and discovering that we are not alone after all. The mystery of 3IATLAS also brings into focus the future of space exploration. If humanity is to continue its journey into the stars, we will need to develop new technologies, new ways of thinking, and new partnerships with other nations and space agencies. The discovery of objects like 3IATLAS reminds us that space exploration is not just about advancing our technological capabilities, it is about expanding our understanding of the cosmos, our place in it, and the potential for life beyond Earth. The answers we find through the study of 3IATLAS and the ongoing search for extraterrestrial life could help shape the future of humanity for generations to come. As we continue to study 3IATLAS and other interstellar objects, we are taking the first steps in a new era of discovery. Whether this object is an alien probe or simply a mysterious space rock, its presence in our solar system has already expanded the boundaries of our knowledge and reignited our curiosity about the universe. The questions it raises are vast, and the answers we uncover may hold the key to understanding the nature of life in the cosmos. And as we continue our quest to understand the universe, we may one day find that the stars are not as distant as we once believed, and that our place in the cosmos is far more connected to the greater universe than we ever imagined. The discovery of 3IATLAS has undoubtedly been one of the most significant events in recent astronomical history. This interstellar object, with its unusual size, strange trajectory, and unexpected lack of cometary activity, has not only captured the imagination of the scientific community, but also of the public. Whether it turns out to be a natural object or an alien probe, the questions it raises about the nature of life, intelligence, and exploration in the universe are profound. The very fact that we are discussing the possibility of an extraterrestrial probe passing through our solar system challenges everything we know about our place in the cosmos and the potential for contact with intelligent civilizations beyond Earth. While it may be premature to jump to definitive conclusions, the implications of 3IATLAS's discovery are undeniable. First and foremost, the presence of 3IATLAS in our solar system underscores the vastness and complexity of the universe. For centuries, humanity has looked to the stars, wondering whether we are the only intelligent beings in the cosmos. The discovery of this object, whether natural or artificial, reminds us that the universe is full of mysteries, some of which we are only just beginning to uncover. Interstellar objects like 3IATLAS challenge our understanding of the nature of space and the forces that govern it. Their existence expands the boundaries of our knowledge and pushes us to reconsider what we know about the solar system, star systems, and the vast stretches of space in between. It forces us to confront the possibility that the universe is not just a random collection of matter, but a place where intelligent life could be scattered across time and space, waiting to be discovered. If 3IATLAS is indeed an alien probe, the discovery would be nothing short of revolutionary. It would represent the first tangible evidence of intelligent life beyond Earth and would fundamentally alter our perception of our place in the universe. For centuries, humanity has speculated about the existence of extraterrestrial life, but we have yet to find definitive proof of its presence. The discovery of an alien probe, silently observing our planet from afar, would confirm what many have long suspected, that we are not alone in the universe. It would validate the idea that other civilizations have ventured into the stars, exploring the cosmos long before we have developed the technology to do so ourselves. This realization would open up a new chapter in the history of human exploration, offering new avenues for scientific inquiry, technological advancement, and philosophical reflection. However, even if 3IATLAS turns out to be a natural object, an interstellar comet or asteroid, the discovery still holds significant value. The fact that an object from another star system has entered our solar system provides a unique opportunity to study an object that has traveled across vast distances, potentially offering clues about the formation of star systems and the building blocks of life. The materials that make up 3IATLAS, including organic compounds and water ice, could provide important insights into the chemical processes that occur in distant star systems. The object could be a time capsule, preserving information about the conditions in its original star system and the processes that shaped it over billions of years. Whether or not it is an alien probe, 3IATLAS offers a rare and valuable opportunity to expand our knowledge of the universe and our origins. In addition, the discovery of 3IATLAS has significant implications for the future of space exploration. It highlights the need for continued investment in astronomical research and the development of new technologies to detect and study interstellar objects. As our technology advances, our ability to monitor and track objects from outside our solar system will improve, allowing us to gain a deeper understanding of the objects that pass through our cosmic neighborhood. The discovery of 3IATLAS underscores the importance of maintaining vigilance and curiosity in our exploration of the universe. Whether we are searching for signs of life, studying the origins of our solar system, or preparing for future interstellar exploration, the study of objects like 3IATLAS will be crucial in shaping the direction of our space missions for years to come. Moreover, 3IATLAS serves as a reminder of the role that scientific inquiry plays in shaping our worldview. The questions raised by its discovery are not just about the object itself, they are about the nature of humanity's search for knowledge. What does it mean to be human in a universe that is vast and full of unknowns? How do we make sense of our existence in the context of an ever-expanding universe? The search for extraterrestrial life and the discovery of objects like 3IATLAS challenge us to look beyond our planet and to consider our place in the broader cosmos. They force us to confront the possibility that we are just one of many intelligent species scattered across the stars, and that our journey is part of a much larger cosmic narrative. Finally, the discovery of 3IATLAS highlights the importance of collaboration and global cooperation in the pursuit of knowledge. The detection and study of interstellar objects is not the work of any single nation or organization. It is a collective effort, one that requires the combined resources, expertise, and dedication of scientists and researchers from around the world. As we look to the future of space exploration, it is clear that the challenges of understanding our place in the universe will require us to work together, pooling our knowledge and resources to address the profound questions that lie ahead. Whether we are searching for signs of extraterrestrial life, studying the origins of our solar system, or developing the technology to explore the stars, collaboration will be key to unlocking the mysteries of the cosmos. In conclusion, the discovery of 3IATLAS has opened the door to new possibilities in the search for life beyond Earth and the exploration of the cosmos. Whether it is an alien probe or a natural interstellar object, it represents a unique opportunity to expand our understanding of the universe and our place within it. The questions raised by 3IATLAS about extraterrestrial life, space exploration, and the future of humanity are questions that we will continue to grapple with for years to come. And while the answers may not be clear yet, one thing is certain: the journey to uncover the truth about 3IATLAS and the universe it comes from has only just begun.